The second confirmed alien moon is very similar to the first, big and strange. Washington. For only the second time, astronomers have detected what appears to be a moon orbiting a planet in another solar system. Just like the first time, this one has traits suggesting that such moons may differ greatly from those populating our solar system. Data obtained by NASA's Kepler Space Telescope before it was retired in 2018 indicated the presence of a moon 2.6 times the diameter of Earth orbiting a Jupiter-sized gas giant about 5,700 light-years away from our solar system in the direction of the Cygnus and Lyra constellations, scientists said on Thursday. A light-year is the distance light travels in a year, 5.9 trillion miles. This moon's diameter would make it larger than any of the roughly 220 ones known to be orbiting planets in our solar system and more than 9 times the diameter of Earth's moon. We don't know the mass, or indeed composition. It could be a rocky core with a light fluffy envelope or a thick atmosphere all the way down to some high-density core, said Columbia University astronomy professor David Kipping, lead author of the research published in the journal Nature Astronomy. Our solar system's moons all are rocky or icy objects. Close to 5,000 planets, beyond our solar system, or exoplanets, have been identified, compared to only 2 such moons, called exomoons. That is not because moons are thought to be any scarcer in other solar systems, but because planets tend to be larger and therefore easier to find, the researchers said. The first exomoon candidate, described in 2018 by the same lead researchers and still awaiting confirmation, is even larger, roughly the size of our solar system's planet Neptune. It is located approximately 8,000 light-years from Earth. Its apparent gaseous composition is unlike any of our solar system's moons. Exomoons are terra incognita, Kipping said, using a Latin term meaning unknown land. We know next to nothing about their prevalence, properties, or origin. Moons may be frequent abodes for life in the cosmos and may affect the habitability of the planet they orbit. We've learned so much about exoplanets in the last few decades, but exomoons represent an outstanding challenge in modern astronomy, Kipping added. The researchers employed the transit method, often used to detect exoplanets. They observed a dip in the brightness of the sun-like star around which the moon's planet orbits when the planet and then the exomoon passed in front of it. The Kepler telescope obtained data on 2 such transits. This is yet another tantalizing exomoon finding, suggesting again that large moons may be present in other planetary systems and that we can potentially detect them, said astronomer and study co-author Alex Teachey of the Academia Sinica Institute of Astronomy Astrophysics in Taiwan. The researchers scanned 70 cold, giant gas exoplanets on wide orbits around their host stars, knowing that 2 such planets in our own solar system, Jupiter and Saturn, are orbited by numerous moons. They found evidence for the one new exomoon, whose size, they said, would earn it the description of being a mini Neptune. We will want to see follow-up observations to confirm its presence, Teachey said. Even so, the present study goes a long way towards ruling out alternative explanations for the observed signals, leveraging more than a decade of experience in the exomoon search and pulling out all the stops. Some skepticism among the community is inevitable and important, but I think the paper lays out a convincing, thorough case.